If you've ever looked up at a starry sky at night from a remote spot, far away from any city and free of light pollution, you may have been astounded by the sheer number of stars that cover the sky. In fact, you may have assumed that the universe is a place densely packed with stars and galaxies. This is partially correct, but only in certain portions of the universe. In fact, whereas galaxies are densely packed with stars, the space between galaxies is mostly empty. And these cosmic voids can sometimes grow to tremendous proportions, generating vast parts of the universe that are nearly totally dark and empty. These are referred to as voids and supervoids respectively. Do you want to find out more about them? Watch this video to find out more. While gazing at a stunning starry sky at night, you would think the universe is pretty uniform, with stars and galaxies distributed all over with no discernible distinctions across regions. That is not the case. In truth, the universe's structure is extremely strange. Let us begin our adventure on a small scale and then expand our vision to observe what happens on larger scales. As you are presumably aware, stars are organized into galaxies, which is a concept you are surely familiar with. Galaxies contain a massive number of stars, hundreds of millions, if not hundreds of billions. In fact, all of the stars visible in the sky are part of our galaxy, known as the Milky Way. While galaxies are massive objects, the space between them is significantly greater. While the Milky Way has a diameter of about 100,000 light years, 1 light year is the distance traveled by light in 1 year. The nearest galaxy, Andromeda, is 2.5 million light years away. It's almost 25 times the size of the Milky Way. Despite the fact that these numbers are already rather large, galaxies are still quite close to each other in astronomical terms. In fact, galaxies tend to gather into groupings due to the influence of gravity pulling them together. These enormous groups are referred to as clusters. The Milky Way is part of the local group, a cluster of around 100 galaxies. And the narrative doesn't end there. These clusters are grouped into even larger structures known as superclusters that include thousands of galaxies. This is where things get really large. Gravity has always been the driving force that shapes the universe, and it continues to play a role at this level as well. In fact, even these superclusters are attracted to one another. However, at this time, they do not form megaclusters or similar formations, but rather longer, thin structures known as filaments. Indeed, if we could see the universe at this scale, it would resemble a massive spider web, but without the regular geometric pattern, with these filaments matching to the net strings. So, as far as we now know what the universe looks like at its biggest scale. These filaments are gigantic formations that span millions of light years. But what lies between the filaments of this massive spider web? Is there anything in the space between these filaments? That's where things get interesting, and we come to the primary topic of this video. The spaces between filaments are known as voids and, in some cases, supervoids. What exactly are they? To comprehend what voids and supervoids are, we must first discuss density. Density is a physical term that describes the amount of matter contained in a given volume. We are all familiar with this concept. We know that ice is less dense than water, or that a copper coin is more dense than the air in a balloon, and so on. But, on a more microscopic level, what does it mean? Density informs us how near atoms and molecules are to one another in an object or substance on a smaller scale. Higher density indicates that the atoms and molecules are closer together, resulting in less empty space between them. Lower density, on the other hand, indicates that atoms and molecules are separated. This principle can now be applied on a greater scale, the universe. In this concept, however, galaxies replace atoms. Densities vary over the universe. Whereas most galaxies are concentrated in filaments, voids are almost completely empty. In reality, the density of these voids is less than 1/10 that of the rest of the universe's average density. As a result, these voids are large regions of space that are relatively empty, with extremely few galaxies compared to clusters and superclusters. Some of these voids can even merge to generate massive ones, which are referred to as supervoids at times. The Boötes vacuum, the largest known supervoid, has a diameter of around 330 million light-years. It's more than 3,000 times the size of our galaxy. It's no accident that it's dubbed the Great Nothing at times. But how did these items come to be, and why are they so vital to the universe? To comprehend the formation of voids and supervoids, we must go back in time to when the universe was still in its infancy. The universe was made up of plasma shortly after the Big Bang, which is often referred to as the fourth state of matter, the other three being solid, liquid, and gas, which you should be familiar with. The three fundamental particles, protons, neutrons, and electrons, in a plasma are not organized into atoms or molecules as they are in the other three states, but are simply free to flow. We can think of it as a chaotic state in which all particles move arbitrarily and have no link with one another. The universe was extremely hot in the beginning. This means that all of these particles were moving at breakneck speed. In fact, particle speed is connected to temperature. The higher the temperature, the quicker the particles move. They were going too fast, in fact, so they couldn't form atoms yet. In order to create an atom, protons must be able to capture the electrons, which won't happen if the electrons are moving too fast. As the universe expanded, it also cooled, and the temperature dropped. At the same time, particles began to slow down, and eventually, protons were able to catch electrons, forming the simplest atom in the universe, hydrogen. This critical stage is referred to as recombination at times. As the temperature of the universe continued to fall, protons, electrons, and neutrons were able to form atoms of heavier elements such as helium, carbon, oxygen, and so on. However, this process did not occur uniformly throughout the universe. In reality, as atoms began to form, some locations developed greater density than others. And it was at this point that gravity began to play a significant part in the fate of the universe. In fact, as soon as the first atoms emerged, they began to attract one another due to the pull of gravity. And as atoms accumulated, they attracted more and more. As these atomic groups grew in size, the force of gravity they imposed on the surrounding areas grew greater, drawing more atoms and growing larger and larger. Hence, regions with higher density grew faster in growth. Regions of lesser density, on the other hand, could exert less pull due to a weaker force of gravity, allowing them to gather fewer atoms. As time passed, the universe grew less uniform. Regions of higher density attracted more matter, while regions of lower density became emptier. The former are now known as clusters and superclusters, whereas the latter are known as voids and supervoids. So that's how they came to be. Okay, we now understand the genesis of these massive zones with few galaxies inside, as well as how, due to their low density, they exert very little gravitational attraction. So, what part do they play in the universe? In reality, these voids and supervoids exert force, but it is of a completely different nature. In actuality, it is a repelling force. What exactly is it? Before we address this new question, we need to take another step back and discuss the composition of the universe. The universe, in fact, is made up of three major components: ordinary matter, and dark energy. What exactly are they? Let us begin with ordinary stuff, which is the simplest. Ordinary matter encompasses all of the common objects, planets, stars, galaxies, and even black holes, or anything else in the universe that we can detect with our sensors, even if it is too far away to observe. While our common sense would assume that these objects make up the majority of the universe, it may surprise you to learn that ordinary matter only accounts for 5% of the universe. Yes, ordinary matter constitutes only a minuscule portion of the entire universe. What about the rest of it? Let us now turn our attention to dark matter. All matter that we cannot detect is classified as dark matter. Wait a minute, how can we be sure it's there if we can't see it? Even though we cannot directly observe it, we may see the effects it has on conventional matter. Dark matter, in fact, has gravitational attraction, thus it has visible impacts on other familiar objects like stars and galaxies. There are numerous proofs that dark matter exists. For example, it turns out that the rotational velocity of stars in galaxies' outermost regions is too fast, and this can only be explained if there is additional matter inside the galaxies that we cannot detect. Another example is gravitational lensing, in which matter's gravitational attraction may curve light from distant objects. The amount of ordinary matter in specific regions of space is insufficient to produce the lensing effect observed for some distant objects, therefore it can only be explained by supposing there is more matter in between, which is indeed dark matter. But wait, what exactly does this dark matter contain? We don't know, is the answer. Because they are invisible to us, it must be particles that do not emit light or radiation, but we have only hypotheses so far. What's more shocking is that dark matter accounts for around 27% of all things in the universe, which is a significant proportion. So we're down to the third and last component of the universe, dark energy. What exactly is it? I realize that may sound disheartening, but the answer is that we have no notion. Yes, this entity represents over 70% of the entire universe, yet we have no idea what it is. The only thing we know is that it is some kind of unknown energy that pervades the entire universe and pushes galaxies away in some way, acting as a repulsive force, the reverse of gravity. This impact is quite important. In fact, the presence of dark energy is the reason why the expansion of the universe is currently accelerating. To return to our primary theme, dark energy is inextricably linked to voids and supervoids. In fact, we can think of voids and supervoids as massive reservoirs of dark energy, like big bubbles that keep expanding, pushing galaxies apart, far apart from each other. We can claim that these interesting items are responsible for shaping the universe in certain ways. When you think about it, it almost sounds like a paradox. Places that are almost empty are in charge of deciding the universe's religion. How strange is that? But in the end, we shouldn't be surprised. We already knew the universe was a strange place. And here is the end of the video. Thank you for tuning in, everyone. Did you find the topic of voids and supervoids interesting? Is there anything else you'd like to say about them? Let me know in the comments, subscribe, and I'll see you on the channel next time.